Hi, everyone. I wanted to take a minute and go over just a couple of things from your homework assignment last night. You do have an answer key posted, but there are a couple of these problems that we didn't really talk about the method for them, and I had you use a graph, but I want to make sure you know how to do it by hand. So what I really want to focus on is this part D. When is the particle moving forward? However, to do that, I am going to have to do a couple of the other pieces, so I'm going to skip around a little bit before I get to part D. So for example, in order to answer that question, I do need a velocity function. So I'm going to head up here to part A and write myself a velocity function. My velocity function is just my derivative, right? So it'd be 3t squared minus 12t plus 9. Okay. And then the other question I'm going to need to know is this one here. When is the particle at rest? Okay, well, at rest means that I'm looking for a place where my velocity is equal to 0. So let's take that velocity that I just found, the 3t squared minus 12t plus 9, and set it equal to 0. Now, what I'm really emphasizing here is doing this without a calculator, because questions like this are completely fair game without a calculator. And that's why I want to make sure you can do this without physically looking at a graph. So to solve this, I'm going to factor. I'm going to pull out this 3. And that 3 is not actually going to matter in the grand scheme of things. I'll show you what I mean in a minute. Like when I'm solving, that 3 doesn't give me a solution at all. Technically, I could divide by 3 on both sides right now and get rid of the 3 completely. So what I really care about is just that piece in the parentheses. And what I want to do with that is factor it. So I need to multiply to 3 and add to 4. So I'm going to say a minus 3 and a minus 1. Which means my times that I'm at rest are at 3 seconds and at 1 second. Okay, so I need that information, right? And I guess, let me do this. I'm going to put this 3 back in here just because in the next step, I don't want anyone to be confused about like why I got rid of the 3. So, okay, let's slide up here to the question I really wanted to talk about. When is the particle moving forward? Okay, so what I want to know is when is my velocity positive, which I think you could do if you were looking at a graph of the velocity, right? But if you're not looking at a graph, how do you figure this out? Well, so what I'm going to do is set myself up a number line here. And my number line is going to start at 0 and go on forever because my number line represents my time values. Okay, so that's what's going down here. These are my times. And the values that I'm interested in looking at are these up here. Okay, the places where my particle was at rest. So I'm going to add those to my number line. Okay, and the reason I care about those is those are the only places where I could have potentially had a change in direction. Because if I change direction anywhere, I have to have a place where my velocity is 0. Now, that's not guaranteeing that I definitely change direction in both of these places, although I do think that is going to end up happening. But so I'm not guaranteed that these are both change in directions. But there's no other place. Like there's no way I could go down here to 5 seconds and somehow turn around because then I would have a velocity of 0 at that time. Okay, so these are the places that I know could indicate a change in direction. And so now what I really want to ask myself is on this interval from 0 to 1, is my velocity positive or negative? Well, the way I'm going to check that is I'm going to pick a number between 0 and 1. So maybe I'm going to pick 1/2. And then what I want to do is evaluate the velocity at 1/2. Now, remember a second ago, I said we were doing this entirely without a calculator. If you go back up to this velocity formula right here, that's going to be a pretty tricky one to plug a 1/2 into. But what I want to remind you is we don't actually care about the value. All we care about is whether it's positive or negative. So what I'm going to do is I'm going to use this version of the velocity. Okay, so this right here. All right, look at me, look at me. I'm going to use that version of the velocity equation. And let me show you why. I'm not really going to say in equals because I'm not doing a calculation. But if I were to plug a 1/2 in for t, I would have this 3, which is positive, times. Now, if I do 1/2 minus 3, that's going to come out negative, times, and 1/2 minus 1 is also going to come out negative. So ask yourself, and I mean, you might be able to actually crunch the numbers and come up with a value there, but all I really care about is, will this come out positive or negative? And I hope that you're looking at that and seeing the two negatives and saying, hey, that velocity is going to be positive. So this that I'm marking up here in pink, this is what's happening with the velocity. Okay, let's repeat that process. Let's pick a number on this interval from 1 to 3. So let's pick 2. And really what I want to know is, what is the velocity at 2? But all I really care about is that velocity positive or negative? So again, using that velocity equation that's up there that's factored, the 3 is always going to be positive, right? Which means it doesn't actually matter, right? Like, it's not going to change whether we're positive or negative. We're just multiplying by positive. 2 minus 3 gives me a negative, but 2 minus 1 gives me a positive. So if I were to multiply a positive times a negative times a positive, my end result would be negative. Okay, so this velocity is negative. Okay. And then I should check one more time. Now, like I said, some of you might be ready to take a leap of faith and say, well, I bet this velocity is going to go back to being positive. I do think that's actually going to work because I gave you a really simple velocity equation here. But that's not always going to be the case. So you really should build the habit of saying, I'm going to pick a number that lives down here. I'm going to pick a 4, let's say, and do the same thing, right? Now, I'm running out of space a little bit, so I'm going to kind of just talk through it. But with a 4 for my velocity, I would have a positive, and a positive, right? All 3 of these would be positive. And so that's enough to tell me that this velocity is going to be positive. So when am I moving forward? I am moving forward anywhere where my velocity is positive, which would be here and which would be here, right? Where my velocity is positive. And so to answer this question, where am I moving forward? I would say on the interval from 0 to 1 and on the interval from 3 out to positive infinity. Okay, that was the big thing that I really wanted to show you, was how I use that number line. I am going to continue on the back page and do part D of that question as well, just to give you practice with one more. You might want to pause this video and try that one on your own, and then just come back and watch the second half of the video if you feel like you really need it, okay? You're not required to watch the entire thing, but I just wanted to give you one more example. So I'm going to head over to that other page. So same as before. In order to answer this question, I do need to start with a velocity function. So 3t squared minus 24t plus 36. And then I'm going to hop down here for when is the particle at rest, and I'm going to set my velocity equal to 0. I'm going to pull the 3 out. And then I'm going to factor. So this is, let's see, I think 6 and 2. Two times 6 is 12. 2 plus 6 is 8. So I get t equals 2 and t equals 6. Okay, so I'm going to use that now to answer this next question. When is the particle moving backwards? Well, let's start with that number line, right? So I'm going to say, here's my 0, right? And then my times that I care about are 2 seconds and 6 seconds. So what those are really doing is establishing where your intervals are. So something is happening between 0 and 2, and it's got to be all the same something. Either it's all positive or it's all negative, because we can't turn around in there anywhere or we'd have another 0. Okay? Something is happening between 2 and 6, and then something is happening after 6. It might be all the same thing that's happening in all three of those places. We don't really know, but that's what we're going to check. So I'm going to pick a number between 0 and 2. I'm going to pick 1. And again, what I'm trying to think of is, what is my velocity at 1? Now, you might be comfortable just plugging 1 straight into your velocity function and finding a value, or at least finding out whether it's positive or negative. But I really like using this method where we just talk about multiplying and getting positives or negatives, right? So if I'm plugging in a 1, my 3 is going to be positive. My t minus 2, 1 minus 2 is something negative. And 1 minus 6 is also something negative. So a positive times a negative means that this region is going to have negative velocity. And so remember, that really means that everything between 0 and 2 has a negative velocity. Okay, let's try again. Between 2 and 6, pick your favorite number. I'm going to pick 5. But you could pick anything that lives in there between 2 and 6. I'm going to ask myself about v of 5. My 3 is going to be positive no matter what. 5 minus 2 is going to come out positive. And 5 minus 6 is going to come out negative. So that's a... Oh, you know what? I just realized on the last one I wrote negative. I meant to write a positive. I'm sorry about that. Because 2 negatives make a positive. On this one, I would have negative velocity. And then my last region is somewhere after 6. So pick something after 6. I don't know, 10. Okay? Doesn't really matter what. And then I'm asking myself, I'm just going to write it down here, but v of 10, same process. Okay? My 3 is positive. 10 minus 2 is going to be positive. And 10 minus 6 is going to be positive. So this is also positive. And so the question now is, when am I moving backward? That would be here where I have negative velocity, right? This whole region. So when I figured out that 5 had negative velocity, I really found out that everywhere between 2 and 6 would have to have negative velocity. And so that's my answer, is from 2 to 6. Okay, that's when I am moving backward. Okay, now that one worked out really similar to the other one because both of these just had nice simple parabolas for your velocity function. I've seen these with much trickier velocity functions, so that might take a little bit more work to do. But if you feel good about this right now, you should be in really good shape. So just want to make sure we had a chance to cover that so you could use that strategy as you work through your assignment today.